Today we will study sign extension and also binary codes. So let's start with sign extension. What is sign extension? The concept is very simple. First of all, just think about it. Let's assume that you are writing a program. You are doing hiring. Okay, you are writing a hiring program, and for that hiring program, let's assume how many applications you will get, how many applicants will come to your, how many applicants will apply. Okay, for that you are having a variable. So let's assume you are having a variable int. Okay, this variable int you are having a means how many applicants you are having. Okay, now just think about it. Let's assume that you are having this int, and in your mind you have that, okay, maybe less people will come. So let's assume you are having this mind that, okay, less people will come. So okay, let me define this variable a as int. This is integer variable. But let's assume that suddenly what happens, a lot of people apply. Okay, a lot of people apply. So a lot of people apply, let's assume. Okay, if a lot of people apply, then what will happen? You are defining this a means number of applicants. This a basically means number of applicants. So you are having this variable for number of applicants, how many applicants are applying. Okay, and you are having this as an integer variable. Integer variable means, let's assume this is 4 bits. Let's assume, okay, let's assume this is 4 bits. Then in this situation I can say, okay, what is the maximum value you are expecting? What is the maximum value you can expect? What is the maximum value you are expecting? Maximum value that you are expecting is basically 15, correct? Okay, you have 4 bits, so the maximum value that you are expecting is 15. But a lot of people apply. If a lot of people apply, then what you will do? Then you will do typecasting. Yes or no? Basically you will shift this data. This data you will shift on long int, correct? So this is what you will do. Okay, you will shift this data into long int. Or okay, so maybe some typecasting or something you will do. Now you will copy this data in 8 bits. Okay, this is called sign. Okay, basically this is the problem, and for this problem we need to study what is sign extension. So this here, the concept of sign extension will come. This data, the same data you want to store in n plus 2 bits. So for this situation we need to study the sign extension. Okay, like how to store, how to copy this data, basically how to copy this data from n bits to n plus 2 bits, how to copy the same data. The data should not change. Yes or no? The data must not change. Now let's see sign extension for unsigned numbers. For unsigned number, what will be sign extension? So tell me, for example, let's assume you have 4 bits, and this data you have in 4 bits, this data you have 101. Then tell me, what is this data in 4 bits? What is this data? This data, what is this data in 4 bits? This is 5. This is the data 5, means number 5. Now you want to transfer, you want to copy this data into 5 bits. Then what will happen? The same data you want to copy in 5 bits. The data should not change. Then what you will do? This is your data 0101. Then what extra you will do? You will put 0, correct? You will put 0. And the same data if you want to put in 6 bits, then what you will do? The same data, then for 6 bits, this 0101, you will put 2 more 0. Okay, so this is the idea. And the same idea you can basically, you can say what is happening here. This is happening that if you have n bits, if you have data, let's assume an, let's assume this is your data an minus 1 and so on, a1. This is your data in n bits. Now this data I want to copy. This data, this is unsigned data. I'm talking about unsigned numbers. Okay, for unsigned numbers I'm talking about. So this data that you have, this data you want to copy, this data you want to copy. And also one more thing, tell me, if my original data was like this, if my original data was like this, if this was my original data, then how to do the copy? Then in the 5 bits, how to do the copy? If this is my original data, then how to do the copy in the 5 bits? So this is my original data. My original data is 1101. This is the original data. Now how to do the copy? Very simple. You will again put 0. You will again put 0, correct? And this is unsigned. This is unsigned. Priyanshu, this is unsigned. So you can notice this is, what is this value? This value 1101. This value is 13. And you can notice this value is also 13. And you can notice this value is also 13. This value is also 13. So this is the same. Okay, so whatever data you have, this is your unsigned data. If this is the unsigned data and you want to copy this data in let's assume n plus 2 bits or maybe n plus 3 bits, then what you will do? If you want to copy this data in n plus 3 bits, then what you will do? You will put extra 3 zeros. These 3 zeros you will put, and the data will be same. So this will be your answer. Yes or no? You will put zeros. These zeros you will put. Whatever data you have, you will put the zeros. Correct? Like in 4 bits, whatever data you have. In 4 bits, if you have this data, 0, 0, 1, 1, then in 7 bits, what it will become? In 7 bits, this will become 0, 0, 0 and 0, 0, 1, 1. Okay, this will become. Now in the 4 bits, if your data is 1, 1, 0, 1, if this is your data, or maybe 1, 1, 0, 0, this data is 12. This is 12. So in 7 bits, what it will become? It will become 1, 1, 0, 0, and you will put extra zeros you will put. Okay, these extra zeros you will put. You can notice this is also 12. Okay, so very simple. This is how we do sign extension in unsigned number. Okay, so very simple. Just put zeros. These zeros you have to put. Very simple. Now let's see sign extension for signed numbers. For signed numbers we have three. Okay, for signed numbers. For unsigned number we have seen. Now we will see for the signed numbers. For signed numbers we have three representations. One is sign magnitude representation. One is 1's complement, sign magnitude, 2's complement. So these are the three representations for signed numbers. Now for signed numbers, let's see. If you are having sign magnitude representation for signed numbers, then what will happen? Okay, you tell me one thing. So let's assume in 4 bits I have this data in 4 bits, and let's see what will be the corresponding data in 5 bits and what will be the corresponding data in 6 bits. Let's see this. Okay, so tell me, if your data is this 0, 0, 1, 0, then what is this data? Can anyone tell me? This data, what is this data? Can anyone tell me? This 0, 0, 1, 0. Remember, I'm talking about signed numbers in sign magnitude representation. So this is a signed number I'm talking about. Okay, so this data is basically plus 2. This is a signed number. Okay, in 5 bits, how to represent this? In 5 bits, very simple. I will put 0. This is very simple. I will put 0, and this data will be as it is 0, 0, 1, 0. In 6 bits, what I will do? I will put 00 and I will put 0, 0, 1, 0. You can notice this is also plus 2. You can notice this is also plus 2. Okay, so there is no problem here. Similarly, if you have this data 0, 1, 0, 1, if you have this data is plus 5, and this same data you can how will you do here? How will you put this same data in 6 bits? Okay, very simple. You will just put a 0, because you can notice this is also plus 5. This is also plus 5. Both are plus 5. This is plus 5. This is plus 5. Now let's see. If my original data is 1, 0, 1, 0, then what is this data? Can anyone tell me? This data is, this is minus and this is 2. This is minus 2. Okay, remember this is minus and this is 2. So this is minus 2. I'm talking about sign magnitude. Remember, I'm talking about sign magnitude representation for signed numbers. So this is minus 2. Now, how to put this minus 2 in 5 bits? Tell me how to put this minus 2 in 5 bits. So this is the data. How to put this data in 5 bits? Should I do this? Is this correct? Tell me. Is this correct? This is wrong, because what is this value? Tell me, what is this value? This value now is 10. This value now is, this is 10. So what should I do? What should I do? Should I do this? Should I copy the MSB? Should I copy the MSB? This MSB should I copy? This MSB should I copy? What is this data? This is minus 10. This is minus 10. So tell me what should happen? Tell me what should happen? So this should happen. Very simple. See, minus 2 in 5 bits. Minus means this is minus. This is minus. Now you need 2. So this will happen. Remember, this is minus and this is 2. See, very simple. This is not hard. This is minus. This will give you minus. And this will give you 2. What this will give you? This will give you 2. So finally, you will get minus 2. Now the same thing. Tell me, this minus 2, how will you put in 6 bits? How to put this minus 2 in 6 bits? Very simple. This will give you minus. This will give you minus. And now you need only 2. You need 2 in 5 bits. So 0, 0, 0, 1, 0. Okay. Very simple. This will give you 2. This will give you 2. And this will give you minus. Okay, so very simple. This concept is very simple, that if you have any number, like in 4 bits, if I have this number 1 1 0 1 1, or maybe 1 1 1 1, or maybe this data. What is this data? Tell me, in 4 bits, what is this data? This is minus and this is 7. So this data is minus 7. Okay, very good. This is minus, this is 7. So this is minus 7, because I am talking about sign magnitude representation. So this is the sign and this is the magnitude. The same data, how will you put in the 5 bits? The same data, very simple. This will give you minus and this will give you 7. Okay, the same data, how to put in 6 bits? This will give you minus and this will give you 7. Okay, so this is the idea. Now the same thing you can write in a formal manner. So what should I write? In sign magnitude, signed numbers, for signed numbers, I am talking about signed numbers in sign magnitude, representation, in sign magnitude representation. So for them, if you have a sign number, like, okay, for example, an minus 1 and so on, a1. If this is your n bit number, if this is your n bit number, then tell me, how will you do? Like, how will you put this number in n plus 3 bits? How to put this number in n plus 3 bits? What you will do? What you will do? Very simple. See, very simple. The sign will not change. Correct? Yes or no? The sign will not change. The sign will not change. So you will put this an, because this an is telling you the sign. This is telling you the sign. So here this will tell you the sign. So this sign will not change. Okay, so just directly put the sign. Okay, and this magnitude will also not change. This magnitude, this will also not change. An minus 1 to a1. Okay, extra bits. How many extra bits we need? How many extra bits? So 2 bits. So I will put 0 0. Is this clear? Tell me, is this clear? So this will be in n plus 3 bits. This you will get an 0 0 an. Okay, and so you can notice, very simple. The concept is very simple, that this will give you the magnitude. This is the magnitude. Okay, so magnitude here also, this is the magnitude. Is it clear? Oh, 3 zeros. Yes, there will be 3 zeros. There will be 3 zeros. Sorry, there will be 3 zeros. Okay, now this is correct. Okay, so there will be 3 zeros. Very simple. So this is the same thing you can do. Remember, if you want, the same thing you can do for, if I ask you n plus 5, n plus 6 bits. If you want n plus 6 bits, then what will happen? Then what will happen? If you want n plus 6 bits, then what you will get? Then this is what you will get. Okay, so the sign will not change. So sign will be an, and there will be 6 zeros. 3 6. So there will be 6 zeros. Okay, after the sign bit, after this is the sign bit, after the sign bit there will be 6 zeros, and then there will be magnitude. Okay, so this is the idea. I hope this is clear. Next is sign extension for signed numbers in one's complement representation. Okay, so let's do the same thing. The same thing we will do now. So tell me, in 4 bits, if you have this data, let me give you this data 0 1 0 1 1 0. If you have this data, then in 5 bits, how to represent this data? In 6 bits, how to represent this data? The same data, how to represent in 5 bits, 6 bits. Let's see another data. So first you tell me, what is this data? Tell me, what is this data? This data in one's complement. This is a signed number in one's complement. So this is plus 6. This is your plus 6 or 6. Okay, both are correct. You can write it plus 6 or you can write it 6. There is no problem. This is a signed number. Okay, 6. You can write as 6 also. There is no problem. But understanding is that this is a signed number. In your mind, you should understand that this is a signed number. So this is 6. So tell me, in 5 bits, what you will get? In 5 bits, you will get 0 1 1 0, and this extra 0 you will put. In 6 bits, you will put 2 extra zeros, and this 0 1 1 0. No problem. Now let's see this one. If I have this data 1 0 1 1, what is this data? Can anyone tell me? What is this data? This data. In one's complement representation, this data, this one means negative. this one means negative, this is negative, this one means negative, and ones complement of this, you find the ones complement of this, that will be 0 1 0 0, so that will be 4, so this will be -4. Now you put this -4 in 5 bits, this -4 in 5 bits in my, okay, -4 in 5 bits, what it will become? -4 in 5 bits. Remember, this is your +4. What is your +4? Your +4 is 0 1 0 0. So 5 bits, this is your +4 in 5 bits. So what will be -4? So -4 will be 1 1 0 1 1. So okay, -4 will be like this. That will be 1, and then you have 1 okay 0 1 1. This you will get. In 6 bits, what you will get? In 6 bits you will get 1 1 and then 1 0 1 1. You can check it out. In 6 bits you will get 1 1 then 1 0 1 1. Can you notice one thing? Can you notice what is happening? See, this sign bit you are copying. If you notice, this sign bit you are copying. This sign bit you are copying. This sign bit you are copying. If you notice, this sign bit you are copying. Here also, this sign bit you are copying. Okay, this sign bit you are copying. So in both the situations, you are copying the sign bit you are extending. Let's see another example. For example, if you have this data, what is this data? Can anyone tell me? In ones complement, what is this data? This data is -0. This data is -0. The same data, this same data -0, how will you put in 6 bits and 5 bits? How will you put? In 5 bits, it will be 1 and then 1 1 1 1. In 6 bits, it will be 1 1 and then it will be 1 1 1 1. So you can again see that this sign bit you are copying. This sign bit you are copying. If I have this data 0 0 1 0, if I have this data, what is this data? This data is +2. This data is +2. How will you put this in the this +2? How will you put in the 4 bits and in the 6 bits? So in the 5 bits, what you will do? Very simple: 0 0 0 0 and then 0 1 0. So you okay. Next here 0 0 0, then 0 1 0. Okay, so here also you are copying the sign bit. This sign bit you are copying. So the same, okay, so this logic you can say. Finally, this is the logic that if your number in ones complement, how to do this? In ones complement, if you have some data, let's assume you have this data, some signed data you have, and your data is an -1, a1. Let's assume this is in n bits. Then how will you put this data? How will you copy this data in n plus 3 bits? The same data, how will you copy in n plus 3 bits? What you will do? This sign you will copy. This sign bit you will copy. Okay. So n plus 3 bits. So this sign bit you will copy total, I can say 3 times. And then, okay, then original data is as it is. The original data is as it is. So an, and then original data is as it is. So now you can notice there are total n plus 3 bits. Is this clear? Now you have total n plus 3 bits. This is n plus 3 bits. Okay. So this an, this sign bit you will copy. Very simple. This sign bit you are going to copy. For example, if I have the same thing, if I want to do n plus 6 bits, then what I will do? If I want to put in n plus 6 bits, then what I will do? Then here I will do an, okay, 6 times, and then the original data. Then the original data an -1, a1. Okay, is this clear? For ones complement. Now let's see signed extension for 2's complement, for signed numbers in 2's complement representation. So here, let's see again the same thing. In 4 bits, if I have this data, let's assume 0 0 1 1. This data I have. In 5 bits, what this data will become? In 6 bits, what this data will become? So tell me, what is this data? Can anyone tell me? What is this data? This data is plus. This is +3. This data is +3 or 3. Okay, 3 is also correct. So this same data, how will you represent in 5 bits, 6 bits? This same data, very simple. Just put 0 and then 0 0 1 1. Just put 0 0 and then 0 0 1 1. Now let's see this data. 1 0 1 0. What is this data? In 2's complement. In 2's complement, what is this data? So okay, remember this is -8. Remember, this is -8, this is 2. So this is -6, because you know this is -8, this is -8, and this is +2. So finally it will be -6. This value is -6. In 2's complement, this is -6. How will you put this -6 here and here? How will you put? In 5 bits, how will you put this -6? Very simple. This will be 1 1 0 1 0, and here it will be 1 1 1. Okay, here it will be 1 1 1 0 1 0. Okay, so like this you will do. Again, you can notice that. So you can notice this is -6. You can check this is also -6. Both are -6. So this sign bit you are copying. This is sign bit. Okay, you are copying this is sign bit. This sign bit you are copying. Here also this sign bit you are copying. Okay, so same, just as 1's complement, same as 1's complement. If I give you this data, like, okay, for example, if I give you this 1 1 1 1, what is this data? In 2's complement, what is this data? In 2's complement, this is -1. This is -1 in 2's complement. So in 5 bits, what will be -1? This will be -1. And in 6 bits, what will be -1? This will be -1. Same, you can notice that. So here also the same thing. This sign bit you are copying. This sign bit you are copying. And next, for example, 1 0 0 0. What is this data? This is -8. This same data you can, okay, how can you write this? The same data. How can you write in 5 bits? It will be 1 1 0 0 0. And it will be 1 1 1 0 0 0. Okay. So again, you can notice this sign bit you are copying. So finally, what I can say, in 2's complement, the same thing I will say. In 2's complement, for signed numbers, then what you will say for the signed numbers, what will happen? So if your data is this, an -1, a1, if this is your data in n bits, then how to copy this data in n+3 bits? In n+3 bits, how will you copy this data? Very simple. Just copy this sign bit you copy. Very simple. Just copy this sign bit, an, and the original data you keep as it is. Okay, so like this. This is in n+3 bits. The same thing you can do for n+6 bits. How will you do for n+6 bits? For n+6 bits, you will do, okay, so this an you will write total an, and the original data will be as it is. an -1, and so on, a1. Okay, so this is the sign extension. Please let me know, did you understand this? Did you understand the concept of sign extension? The concept. Okay, so let's move on. So let's do this one practice. For practice, let's do. If I give you this data, I want to transfer. So let's assume I have this data in my computer. In my register, there is a register. Let's assume this is a register. Register means basically it is a storage device. Okay, register. This is register. Register means this is a storage device. So here I have data. So let's assume this data I have 1 0 1 1 0. This data I have. Now I want to transfer this data from 5 bits to this data. The same data I want to copy from 5 bits to 7 bits. Okay, 1 2 3 4 5 6. I think 1 2 3 4 5 6 7. Okay, so the same data I want to transfer into. So here you have 5 bits. This data you have 5 bits, and I want to transfer this data into, let's assume, 8 bits. Okay, let's take 8 bits. Let's take 8 bits. So in 8 bits, I want to transfer this data. Now tell me, so what to do? Now tell me what to do. If I have this data, then how to transfer this data into these 8 bits? What should be your question? You should ask, what is this data? Is this signed or unsigned? The first question you should ask is, what is this data? The first question you should ask, that is, what is this data? Is this data signed or unsigned? So let's assume this is unsigned data. Let's assume this is unsigned data. This data is unsigned data. Now what will be the answer? If I assume this is unsigned data, then what will be the answer? In this situation, what will be the answer? If I assume this is unsigned data, then very simple. Then it will be very simple. Just, okay, you will put extra zeros, you will put. These zeros you will put and the original data will be same. So these zeros you will put. Okay, very good. So you will ask, what is this data? This is unsigned data. If this is unsigned data, then this is how you will do. Now, if I tell you that this is signed data, then what you should ask? If I tell you this is signed data, what is the next question you should ask? The next question you should ask, what is that? That is what system? The next question you should ask is which system. So let's assume that signed data I am representing. Let's assume this signed data I am representing in sign magnitude system. This is signed data I am representing in sign magnitude system or sign magnitude representation. Okay, so then in this situation, what will happen? This is the sign data in sign magnitude. Then what will happen? Then it simply means this is the sign number. It simply means this is the signed number. This is the sign. This is the sign. It means this is the sign. This is the sign. Okay, so sign you will keep as it is. Then you will put some extra zeros. Some zeros you will put. Some extra zeros you will put, and then your original data 10110. This is what you will do. Okay, very simple. Okay, very simple. So in sign magnitude system, what you do? You put this sign. You copy this sign. This sign you will copy. This is sign you will copy, and some extra zeros you will put. So this sign you will copy here. Okay, and these will be some extra zeros. These will be part of magnitude. They are the part of magnitude. Sorry. So 3 zeros you will put, and the magnitude is 0, 0, 1. So this is the magnitude. Okay, this is the magnitude. So the answer will be 1 0 0 0 and then 0 1 1 0. So this will be the answer. Remember, this sign you will copy. This is sign. This sign you will copy, and then you will put some extra zeros. Some extra zeros you will put. So these extra zeros you will put, and then this is the magnitude, and this magnitude you will copy. Okay, so this is your magnitude that you will copy. So this magnitude you are copying. Okay, please tell me, did you get it? So this is the magnitude, and this magnitude you are copying here. So this magnitude will basically become the whole thing. This whole thing will become like this. Okay, is this clear to everyone? Tell me. So very simple. So this will be okay, 1 0 0 and then 0 1 1 0. Now let's see if the data is unsigned. If the data is signed, and let's assume in 1's complement system, in 1's complement representation, the data is in 1's complement representation, then what will you do? This is very simple. Just copy the sign bit. Just copy the sign bit 3 times. Okay, just copy the sign bit 3 times, and then you will just get the original data. This will be your answer. And the same thing if I do for sign data, if this data is in 2's complement representation, if this is in 2's complement representation, then what you will do? Very simple. Just copy this sign bit you copy, and the original data is 1 0 1 1 0. This will be your answer. Okay, is this clear to everyone? This sign extension, this concept of sign extension, is this clear? Very simple.